All right, hey, welcome back, and welcome to class 2 of week 1. So this will be for either Wednesday or Thursday's class, depending on which section you're in of CSE 224. So this will be a shorter video than video 1, and we'll probably actually do some of the video 1 material in today's class, but here's some additional material that we can start working through. So let me make a comment up front about programming in C. So everybody in here should have taken CSE 121 or the equivalent, which means you should know how to program in C already. I'm not planning to make this course a lot about C programming. This is really a tools class. It's about programming tools, but I'm also going to do some touching on more advanced concepts in C, such as pointers, that we'll be using in winter for CSE 222, the data structures course. But when I'm talking about pointers, if you don't understand basic C, if you don't know how to write a main program, how to compile a C program, things like that, those lectures are not going to be very meaningful, and you're going to find yourself in a difficult situation in winter term. So you want to make sure that you are pretty proficient at C programming at this point. And if you don't feel like that's the case, if you took CSE 121 a while ago, or if it didn't quite make sense, I want to offer an online resource that that might be helpful. So the site is w3resource.com. I have no affiliation with this site other than I've looked around for practice sites, and this one seems pretty good. There are two main sections. The first is a series of tutorials, and the second is a series of exercises. Mostly I send students to the site to work on the exercises, but if you want some tutorial background, and yeah, it has lots of advertisement on it. If you want some tutorial background, there's a number of topics here in C. So if you're not sure how to deal with C arrays, click on C array, and you can read about it in here, see some examples, and so on and so forth. But the part that I think is most useful on this site is the exercises. And basically, for each different topic, you can find a series of problems. So basic declarations and expressions. And there's 150 exercises here. And these start off not very challenging, right? Write a C program to compute the perimeter and area of a circle, or a rectangle, right, with a given height and width. But they get increasingly complex. And there's two sections of basic exercises, or again, if you're unsure about arrays, here's 107 exercises related to arrays. Write a C program to store elements in an array and print them. And you can see solutions, but once you look at the solution, you don't really have a chance to do the work yourself. So I think that these are useful if one, you want to assess your understanding of C, or if you're cognizant of needing to brush up on C, right? Doing some reading and practice, and then coming to these exercises to see where you are. And I certainly don't recommend doing every single exercise from beginning to end, but maybe start with the beginning, start with basic declarations, and just kind of look at these. And if it's like, yeah, I can definitely do that, don't do it. Yeah, I can definitely do that, don't do it, right? But do a few of these, and make sure you're being honest with yourself, and maybe do one out of every 10 problems, one out of every 20 problems, or become convinced that you absolutely understand this material, and then go on to the next section. So more basics, and some algorithm questions, and so on and so forth. So like I say, that's a resource that that you can use. Don't do this, don't go to Chegg, but if that's useful, I think it's a pretty good site, so just wanted to put that out there. All right, so let's look at some commands and options that we can work with in Linux. So I'm going to work on the Linux server. I'm going to go into my NMacias account, and we're just going to jump into this. So we know, for example, that we can write a hello world program, right? So let me make a main.c. And we'll take this simple, hello world program apart in a later class. But this was, sample hello world that we worked on last time. And I can look, there's my main.c. I can compile it like this. And if I run my program, I can say /main. It executes my program and it prints out hello. So on other systems, you may be used to putting this /main in front. On this server, we don't have to do that. We can actually just say main, and it will run that main program for us. And if we copied main to main2, right? So I've got a main2 in here also. I could say main2, and it'll go ahead and run that program for us. But of course, if I try to run a program that doesn't exist on the system and isn't in my directory, I'll get a message saying command not found. So why is it that we can just say main instead of /main? Well, this comes down to something called a path. And you'll play around with variables in the practice problems that we do in class today, but let me give you a sneak peek. There's this thing called a variable named path, and if I look at the contents of this variable, it's set up like this. And so what this path is a series of directories. The first directory is user local sbin. The next is user local bin, and then user sbin, and so on. And when you type something on the command line, and it's not a built-in command like cd or pwd, the operating system, the shell bash, looks for a file with this name in each of these directories in order. And if it finds a file named date, in this case, in one of these directories, it'll execute it. And so when I say date, it shows me the date, and where is it finding it? It's finding it under /user/bin. And if I look under user bin, yeah, there's user bin date. It's sitting in that user bin directory. So as it went down my path, when it got to this directory, it looked in there and said, okay, is there a file named date inside there? And it found this file and said, yes, there's a file named date, and so it went ahead and executed. So the whole trick to being able to say main instead of /main is that one of these directories in here is just a single dot. And dot is a symbol which represents whatever your current directory is. So right now I'm sitting in /home/nmacias. Dot means this directory right here. And so if I say main, it's going to look in home nmacias for a file named main. Now if I change into a new directory, dot means this directory, home nmacias new, and if I say main, it doesn't find a file with that name in any of these directories, nor in the directory dot, because right now dot is /home/nmacias/new. So short version of this is, because we have a dot in our path, if we have a file in our current directory that's executable, we can just type its name and it will go ahead and execute that for us. But path is just one example of a variable, and in bash, so bash is the shell that we're using. Bash is the program that actually listens when we type and also generates output in response to it. So there's a program running right now that's waiting for input. That program is called bash. And in bash we can have variables just like we have variables in a programming language. And giving a value to a variable is very straightforward. I could say, my variable equals 12. Well, I've defined a variable called myvar, and I've given it a value 12. And if I were to just type the command set, I get a whole bunch of output, but somewhere in that output I can see my var is equal to 12. I can also see that my path was equal to that thing that we saw earlier. And if I say my var equals ha ha ha, and I say set, well, now my var is equal to ha ha ha. So we can create variables and give them values by just using an equals sign. And so I could say my var equals, this is a test. Well, if I try to do this, I'm going to get an error. Because spaces matter in Bash. And when you use an equal sign to assign something to a variable, it expects variable equal sign value with no spaces. And this space right here is telling it, okay, so this is supposed to be a new command called is, and it doesn't know what that means. So this is where quotation marks can come in handy. We can say my var equals quote, and now these spaces inside are just another character. And so if I do that, my var equals this is a test, and I say set, I can see my var is equal to this is a test. And here it's using single quotes just to show me that this is all one thing in some sense. All right, well, we don't want to have to say set every time we want to see the value of a variable, so we can use the echo statement. So echo by itself just prints an empty line. If I say echo hello, it says hello. If I say echo this is a new test, it says this is a new test. So echo is like, you shout at a wall and it repeats back to you. If I say echo my var, it's just going to say my var. But if I put a $sign in front, echo $sign my var, it will show me the value of that variable. This is a test. And now if I say my var equals 12 and I echo my var, it shows me the value 12. So we can use $signs to check the value of a variable, and we can use equal signs to assign. So I could say x equals 12, y equals 23, z equals 101. And if I echo $sign x, $sign y, $sign z, I get 1223101. Now these things are just symbols. They're just collections of characters. If I echo $sign x plus 1, I get 12 plus 1, right? The 12 came because that's the value of $sign x, and then there's the plus sign, and there's the 1. If I echo $sign x plus $sign x, it gives me 12 plus 12. So it's not actually doing arithmetic for us. But we'll learn how to make that happen later. Alright, so we want to be comfortable working in this environment. We want to be able to manipulate the operating system, whether that's setting up variables or what we're going to call aliases or whatever. So one thing we need to do sometimes is stop the system from doing what it's doing. So for example, I have a program in my current directory called loop, and loop just keeps saying hello Nick. And it's an infinite loop, so if I type something like stop or exit or date, it's ignoring me, right? It's stuck in a program right now. So the proper way to get out of that is to use what's called Control-C, and it's pretty simple. Just hold down the control button and press the letter C. And you'll see this written up in the text and in the notes as either CTRL-C or more commonly just a caret followed by a C. And in fact, when you do this on the command line, it actually printed out a caret followed by a C. And once you hit Control-C, usually that ends whatever your program is that was running. So if I run this again, just hold down Control, press C. Now, some people get in the habit of using Control-Z, as in zebra. Don't do that. That does not actually end the program. We'll talk about what Control-Z does later when we discuss processes, but for now, use Control-C when you want to actually end a program. And the other control that's useful to use is Control-D. And Control-D you use when you want to say I'm done typing in input. So if you have a program that's reading input from you, Control D will get you out. For example, BC is a calculator program, so I can type in statements like 2 plus 3 plus 4 or 2 times some number. When you're done with that, hold down Control and press D, and that takes you out of the program. If I'm sitting here at my prompt and I hit Control D, that actually logs me out because it takes it as meaning I'm done typing in input. So let me log back in again. And you notice when I log in, I'm saying SSH $test. Well, what is that doing? On my home Linux system, I have a variable set up called test. And test is equal to nmacias@linuxengrcs.com. So when I SSH string test, this says replace $test with the value of that variable, which is this string right here. And so it thinks I'm saying SSH, my username, at the server name, and that logs me in. In video 4, I'll show you how to set up this automatic login so you don't have to type in passwords every time. But if you try to do this, it'll ask you for a password. Alright, a couple of other things that are useful about working in Linux. If you type the word history, you will get a list of all of your commands that you've typed. So since I created this account, I've typed 775 commands, and I can get back to any of those commands at any point. For example, if I wanted to get back to, I don't know, maybe I wanted to set my var equal to ha ha ha, that was command 747, I can just say exclamation mark 747, and it recalls that command. And now if I echo my var, it's equal to ha ha ha. You can also repeat your previous command by just saying 2 exclamation marks, and that just repeats your previous command. But a more useful option is to use your arrow keys. If I hit the up arrow key, it'll recall my previous command, and each time I hit an up arrow, it'll go back to the previous command. And if I hit a down arrow, it'll come forward through my history. And I can use the left and right arrows to edit on this line. So I could say let's VI new loop and get into an editing session. And each time you come back to your prompt, right, this $, hitting an up arrow key will bring you back to the most recent command. So it sort of resets where you are in your command recall. And there's a lot of details that you can get into on this, but just being able to go back and pull a previous command back can be pretty useful. The other thing you can do, but this is kind of dangerous, is you can say exclamation mark and put in 1 or more letters to recall the last command that started with those. For example, I want to repeat my clear command, which clears the screen. If I just say exclamation mark CL, it will go backwards through my history, find the first command that starts with CL, which would be clear, and it clears my screen. If I want to repeat my history, I could just say exclamation mark H, and it will find history was the most recent command. The danger with this is, of course, you know, you're trying to recall one command, but you forgot that you did something else that started with the same letter or letters, and you might pull back the wrong command. And if it's a command that, you know, removes all the files in your directory, you can get yourself in trouble like that. All right. What else can we do to make our life a little more comfortable? Let me make a file. This is a file with a long name. And I'll put a few lines of text in here. Alright, so if I do an ls, I can see I've got this file called, this is a file with a long name. And I want to edit that again. Well, maybe I can go back and I can, you know, recall a VI line. But maybe I want to do something different. Maybe I want to compile this. Maybe I want to change the name of it. So you can use a tab key, and in the instructions this is usually written as just angle bracket tab, and that just means hit the tab button. So if I say VI and I just hit a tab, it doesn't show me anything. If I hit a tab a second time, it will show me all the things that I could be typing at this point. All right, so let me make a couple of files. All right, so I've got loop, loop 2, and loop 3. Suppose I say VI L. All right, and instead of typing loop or loop 2 or loop 3, I'm just going to hit a tab right now. So I've typed VI space L, I'm going to hit a tab. It will complete what I'm typing as far as it can without ambiguity. In other words, if I'm trying to type a file name that starts with L, I probably meant loop, loop 2, or loop 3. But it doesn't know which one I meant, so it only fills in the first 4 letters. And if I hit tab a second time, it'll show me my options. And now I can say, oh yeah, I meant loop 2, and I can type 2 and edit it. So if I want to edit, this is a file with a long name, I could just say VITH and hit a tab, and it fills in the rest of the line for me. So tab is a nice way to complete what you're typing on a line, and that can be pretty useful. All right, let's go back to set, and let's look at some of our variables that are defined. And there's a variable here called PS1. And PS1 is equal to, and there's this big long string with lots of strange characters in it. PS1 is what's called your prompt. It's this thing that we're seeing here, my username at my hostname, colon, tilde, and a $sign. If I say PS1 equals hello, instead of printing all of that stuff, it'll simply say hello when it wants me to type something. So I can say history, and I can say show me my current directory, and this is the prompt coming from the system. If I say PS1 equals quote greater than, now it prompts me with this greater than sign. So if I want to put my prompt back to what it was, easiest way to do that, log out, log back in. And now if I look at PS1, it's equal to this big long thing. Well, these are all different hooks that we can put into this variable that change what is displayed when we get a prompt. So on my home system, I get a prompt which is a number inside brackets, and if I look at my history, that's the number of the command that I just executed. So 2005 will be command number 205, and that's just set up by using a / exclamation mark to get the command number. So there's lots of things you can set up with that. And all of these commands are set up for you inside a file in your home directory called .bashrc. And you can put whatever you want inside this file. So for example, there's a line in here which controls what PS1 is equal to. I could add a line to the end of this which says hello Nick, have fun. Today's date is, and then I could run the date command. Alright, so now every time that I log in to the Linux system and I start that bash shell, it's going to say, hello Nick, have fun, today's date is, and then show me the date. So this bashrc file with a period in front, you can put whatever initialization you want inside here, and this is part of how you can customize your environment. So another thing you'll see in here is this command called alias. And for example, alias basically lets you say, new command equals, and I can type in whatever I want that command to represent. So, echo, this is a test. And now anytime I say new command, this part right here, it will do whatever this is. Like echo, this is a test. So for example, maybe I do gcc-o main main.c all the time, I can make a command called C. And by just typing C and hitting enter, the shell will execute this command. Compile main.c, put the output in a file called main. Well, I don't have a main.c, but if I did, that would be a one-character way of compiling it. Now, when I log out, this alias goes away, but if I take this line and I put it inside my .bashrc file, it'll get executed every time I log in, and I'll always have this alias available. So if you don't like typing gcc-o main main.c, you can make yourself a shortcut for it. So those are some examples of things that we can do that will let us sort of tailor our environment to our liking and make us a little more efficient and comfortable working in Linux. Alright, last piece I want to mention here is the manual page command, which is just man, M-A-N. And if you have a command like ls and you want to know more about it, you can say man space ls. And you get an online description of everything you need to know about the ls command. Its name, a short synopsis of how you use it, ls with some options and some files, one-line description, and then a series of modifiers that you can make. For example, ls-a says, do not ignore entries starting with dot. Right? Well, what does that mean? When I do an ls, here's the files that I see. What about that file .bashrc that we were working with? Well, by default, ls doesn't show file names that begin with a dot. But if I say ls-a, hey, there's my .bashrc file, along with a bunch of other what are called hidden files that exist but are normally not shown by the ls command. If I do an ls-b, it does something else. If I do an ls-uppercase b, it does something else. When you're looking at a manual page, you can hit a space bar to go down to the next page. And there's all these different options, right? List entries by columns, list directories themselves, not their contents. And ls, normally we just say ls enter, but it's a pretty complex command. It has all these different things that we can do to modify its behavior. These are called switches. And most commands take a number of switches that we can use to tailor its behavior. And for example, if I say ls-l, I get all of this detailed information. Maybe that's what I always want to see. So I could say, alias dir equals quote ls-l. And now when I want to see a list of files, instead of saying ls space -l, I can just say dir, and there's my list of files. So the manual pages are extremely useful, and like I say, most commands have a number of options on them. That's the date command. The gcc command has a lot of information, a lot of options, a lot of ways to modify it. And you can search for patterns in here by saying / and search for, some pattern like opt. And you don't usually just sit down and read something like this from beginning to end, but it's a holding area for a lot of useful information. And once you've worked with these pages enough and you know how they're organized, you can start jumping around using searches to move from section to section and find information in there relatively easily. Alright, so that's the manual command, and if you want to know more about it, of course, you can get the manual page on the manual command and read all about what this command does.